Welcome to this explainer. Today, we're diving straight into how a system called WARDEN is completely flipping the script on how we govern modern artificial intelligence. We're moving away from this idea of treating AI as some kind of unexplainable, mystical magic, and instead, we are looking at it as an explicit, observable mechanism.
Here is our agenda for today. We're tracing a zoom-out arc, starting with the myth of monolithic AI, then moving through cognition as an explicit mechanism, the inverted evidence triangle, temporal trust, governing distributed intelligence, and finally, the human command layer. Let's jump right in. Section 1. The myth of monolithic AI, breaking the illusion of the single artificial brain. We're going to kick things off with a paradigm shift that is going to completely shatter how most people visualize AI today. We constantly hear phrases like, the AI decided, the AI reasoned, the AI failed, hallucinated, or acted, right? We hear this language absolutely everywhere, in the news, at work, in casual conversation. But this language is incredibly misleading. Why? Because it assumes intelligence lives inside a single, neat little box. It completely assumes a monolithic brain. The old assumption was that we were dealing with monolithic intelligence. One brain, one box, one unified agent. But the reality? It's distributed cognition. Modern AI is actually a temporarily unstable network of highly fragmented components. We're talking foundation models, specialized agents, APIs, persistent memory databases, and network infrastructure, all interacting across a massive ecosystem. To actually govern AI, we can't just watch one single model. We have to govern the entire distributed environment. That brings us to Section 2, Cognition as Explicit Mechanism. Intelligence is not mythology, it is architecture. Influenced heavily by cognitive scientists like Joshua Bach, WARDEN treats distributed cognition as a strict, explicit architecture. It literally breaks the mind down into observable mechanisms like memory or attention, interacting across a layered operational infrastructure. And the reason this matters is huge. Once you stop treating AI as a magical black box and start treating it as an operational architecture, you can actually audit the pieces. Governance finally becomes a reality. So instead of asking a vague, unhelpful question like, did the AI give a good answer? WARDEN gets surgical. It tracks very explicit mechanisms of cognition. It's looking at goals and intent, internal models, attention and focus, persistent memory, active representations, simulation, and self-modeling. If a system forms an intention, calls an API tool, changes a network state, and then records a memory, WARDEN is tracking that entire causal chain in real time. We're governing the mechanisms right at their source. Moving on to Section 3, the inverted evidence triangle. Broad observation, narrow authority. Let's look at how WARDEN actually governs these mechanisms. Now, there is a massive, absolutely crucial rule governing this entire architecture. Observation is not authority, and awareness is not control. Just because a system or a specialized agent within a swarm has the broad awareness to understand an environment, it absolutely does not mean it gets the broad control to act on it. WARDEN manages this using a downward flow called the inverted evidence triangle. First, you observe broad surface signals, collecting tons of conflicting data from networks, sensors, and models. Then you interpret and add context. Third, you reduce that evidence and estimate your confidence. Fourth, you recommend an action. And finally, step 5, you authorize narrowly. It doesn't force a fake, clean certainty. It preserves the contradictions. By the time we reach authorization, actions are strictly bounded by validated confidence. Section 4. Trust is strictly temporal. The half-life of operational evidence. This directly attacks a huge mistake in modern cybersecurity, treating trust as a static, permanent state. Think of trust like a VIP backstage pass that just evaporates the second you act suspiciously. WARDEN uses a real-time factor, or RTF. At T0 seconds, a signal might be highly trusted. But say at T plus 5 seconds, the environment shifts. At T plus 10 seconds, contradicting evidence appears. By T plus 15 seconds, that trust confidence has severely decayed. Every single piece of operational evidence has a strict half-life. The system is continuously asking, is this identity still valid right now? Which leads us perfectly into Section 5, Governing Distributed Intelligence, when intelligent swarms interact. Let's zoom out from the single system and see what happens when a whole fleet of AI agents operates together. Imagine an AI agent executing its APIs flawlessly, reasoning perfectly, and using totally valid credentials. Locally, it looks incredibly healthy and competent. But here's the danger. An AI component can be locally highly competent, yet its local objective could completely diverge from the overarching system policy. It can literally become a threat to the global alignment of the entire fleet. And this is exactly why traditional authentication just doesn't cut it anymore. Because multi-agent systems delegate tasks, share persistent memory, and develop emergent strategies, Warden has to continuously audit their behavioral relationships. It compares declared intent against observed action. It checks local goals against system policy. It tracks current versus historical behavior, validates actor claims against machine evidence, and verifies memory against new evidence. It's actively governing the distributed cognition of the swarm to ensure global alignment. To achieve what is called governance dominance, Warden utilizes spatial awareness. But actually, scratch that. It's not just geographic location. It's architectural awareness. It means understanding position, relationship, trajectory, and change across network, runtime, and physical spaces. A network event might seem harmless on its own, but when correlated with a sudden change in an agent's physical trajectory, Warden can detect when a trusted actor goes rogue. It gives security teams context that is just impossible to get from traditional network logs. Finally, Section 6, the human command layer. Warden Electron comes online. For our final zoom out, we really have to ask, how does a human operator actually control all of this complex, distributed cognition? The answer is Warden Electron. This isn't just some passive monitoring dashboard showing you CPU usage. It's a dedicated cyber command interface. Think of it as the human-in-the-loop black box layer for AI infrastructure. It gives humans the ability to see exactly what the AI observed, which signals disagreed, and exactly how trust was calculated. In practice, this creates a brilliant awareness matrix. Rather than dumbing complex infrastructure down to a simple, binary, trusted or untrusted score, Warden preserves signal disagreements. Say you have Agent X. Its identity is valid, the network is expected, but its behavior is abnormal. Because Warden preserves these contradictions, the system doesn't act recklessly. Policy restricts it, and the decision is to simply observe. Agent Y is compromised and suspicious, so we isolate and sinkhole. Agent Z is fine, so we allow. It gives operators a true operational picture rather than hiding the uncertainty. While the AI infrastructure does the heavy lifting of correlating all these anomalies and surfacing risks, it fundamentally lacks the authority to act on its own in high-impact scenarios. Warden relies on a very specific decision vocabulary: allow, observe, challenge, restrict, decoy, isolate, sinkhole, and human review. The entire goal here is controlled autonomy, ensuring explicit human approval remains squarely in the loop. So as we wrap up this explainer, I want to leave you with a final, provocative thought. Once intelligence becomes architecture, how do you govern that architecture without forcing it back into one artificial mind? Warden's answer is evidence first, context preserved, authority bounded. The real question is, are you prepared to govern your AI systems with this level of observable mechanism? Thanks so much for joining me, and I'll catch you next time.